to solving technical coding interview questions. The question before us is search a 2D matrix. Or to write an efficient algorithm that searches for a value in an n by n matrix. This matrix has the following properties. Integers in each row are sorted from left to right. The first integer of each row is greater than the last integer of the previous row. Okay, so we're given an example here. They say you have 1357 and we have a target value that we're to search for. So we'll return true if we're able to find 3. Here we're finding 13. We'll return false because we cannot find 13 there. So let's go through our method, which is the Umpire method. So first we're trying to understand the problem. There are certain things we need to take into cognizance. Number one is that the integers are sorted from left to right. That's a good information. And another important thing is that the first integer of each row is greater than the last integer of the previous row. So that means 10 is greater than 7, 23 is greater than 20. Okay. So, and we are told to return false if it is not there. That's pretty clear. So we can look at the edge cases. Immediately we see that the matrix is empty. We can quickly return false. So that's one edge case. Alright. So the next phase is for us to go through the match phase. So how can we match this to problems that we have seen before? Very quickly we can see that this is close to binary search because we're trying to do a search and we know that the matrix is sorted row by row, so a binary search. So based on that we go to the plan phase. So we plan how we're going to go about it. So what we can do is we can take our target and start from the first row in our matrix, and we divide our first row into 2 so that we can make use of this sorting information. So we divide the first row into 2. We check the midpoint. If the midpoint is greater than the target, then we know that what we're looking for will be on the left side. So we make our high we move our eye to the midpoint. Then we continue to divide again. Alright. If the midpoint is less than the target, then we know that what we're looking for will be on the right. Okay. So yeah, that should work. Then if we also need to check if the midpoint is less than the target and the last value in that particular row is less than the target, then we know it is there. Yeah, we know it is there. If the last value and the last value is greater than, the last value is greater than the target, then we know it is there. But if the last value is less than the target, then we have to go to the next row and repeat the same thing. Okay, so we are beginning to have an idea of our plan now. So just to put it down, what our plan is. So first is we take each row, we divide the row and get the midpoint. So we divide the row and get midpoint. So for us to get the midpoint, alright, that's number one. Number two is we check if the midpoint is greater than the target. If the midpoint is greater than the target, then we search for it in the left side. That's the left side of the list. If it is not, we check that the last value is greater than, we check if the last value is greater than the target. If the last value is greater than the target, then we can say for sure it will be on the right side. If we cannot find it there, then we return false. But if the last value is less than the target, we will have to move to the, if the last value is less than the target, we'll have to move to the next row. So we'll continue like that until we get to the end of the matrix. So we do that for each row. So let's go to the implementation phase now. We're here. Then later we'll come to the review and the evaluate stage. Alright. Okay. So let's see how we can implement this. Cool. So what we do now is we iterate through the row by row. So for row in, immediately we can check if the length of the matrix is equals 0, we can return false. That's an edge case. And for row in matrix, So the low side will be equals to 0. The I will be equals to the length of the matrix, length of the row minus 1. We'll explain that shortly. Then we get a midpoint, which will be low plus I low plus I divided by 2. To avoid the integer, the overflow problem, we had low plus this. Yeah. Okay. So I think this is supposed to be I minus low to get the length. I minus low. Alright. So the next thing we need to do now is we take the first row down. We got the midpoint. So we say if the target is in the matrix, we get the row, and from the beginning, okay, we need to check if the midpoint is greater than the target. Then we return true if target in the matrix, the row, from the beginning to the midpoint. Okay. Else we return false. But if the midpoint is less than the target, the midpoint is less than or equals to the target, that's for us to check on the right side. So we need to check the last element in that row. If matrix of the row and the last element, if it is greater than the target, because we know it is sorted, then we know it's there, we return true if target in matrix of the row from the midpoint to the end, else we return false if it's not there. So that's so far what I feel we should have there. Then we cannot do a walkthrough to see whether our code will work. So let's now do a walkthrough and see whether our code will work. So let's copy this. Yeah. And we're going to here now. So we paste here. Great. And let's also get our example. So copy that. Okay, good. So we need to walk through our examples now. Let's walk through our examples. So these are matrix. The length of our matrix is not 0, so we skip this. For row in matrix, so our row, it's 1, 3, 5, 7. So this is where we are now. Our row is 0. The length of our row is 4. So this gives us 3. So we say 4 okay. So to get the length, we say, to get the midpoint, we say 3 minus 0. We divide that by 2. That gives us 1. And we had something is wrong with our code there. Because it will be, yeah, it's correct. So our low is what? 0. So we add 0 there. That gives us 1. So let's put in the indices. So this is 0, this is 1, this is 2, this is 3. So our midpoint is 1 because the I is 3, low is 0, so 1 plus low. Now there's an error here. We need to look at the nums, that is the row of midpoint. So we have to have a row here, the row of midpoint. So what is the row of our midpoint? Our midpoint is 1. The row of our midpoint is 3. So we say if 3 is greater than the target, what's our target? 3. No, 3 is not greater than our target. Okay. So what do we do? So the value in the midpoint is not greater than the target. So that will go to our else, and that will not be what we need. So because the else we go to okay, it must still be true anyway. So the else will be we check if the last value in our so we don't need matrix here. This is just supposed to be row, so we don't need this. We just say the row, what's the last value? There's 7. If 7 is greater than the target, then we know it's on the right side. Then we return true if the target, we delete this one. If target in the row from the midpoint, what's our midpoint? Is 1. So row from 1, that is from 3. Yeah. So this will return the value. So this will return true. Okay. So that's correct. So let's pick one more example to go through, and we adjust our code here. So this is supposed to be row of midpoint, and this is not needed because we're already picking each row. Alright, so one more example for us to look at. So this example, yeah. Alright. Okay. So let's paste it there. So we have the other example now. So let's see again. You can get rid of this one. Let's get rid of this one first. We're done. let's paste the next one. Alright, so we're using this now. Okay, so we follow the same thing again. Good. So we pick our row. This is our first row. The length of our matrix is not 0, so our first row is 1, 3, 5, 7. Our low is 0. Our high is 4 minus 1, and that gives us 3. Our midpoint is 0, which is the I, 3 minus 0. This gives us 1 plus 0. This gives us 1. Then the row of midpoint, so we number this is 0, 1, 2. So the row of our midpoint, what is our midpoint? 1. The row of midpoint is 3. Is 3 greater than the target? Our target is 13. No. So we go to the else part. We check if the last element in the row, what's the last element? 7. If it is greater than the target, so is 7 greater than 13? No. Then we move to the next row. So we come here now. So our next row becomes 10, 11, 16, and 20. All right. So the length of the row is 4. We can clean up this for the next one. It's 4, high is still 3, so low is 0, high is 3 minus 0, so this gives us 1. The row of midpoint is 11. 11 is it greater than the target? That is 13. No. Then we check the last element in the row, which is 20 now. Is 20 greater than the target? 20 greater than 13? Yes. So we expect that the value should be here. So we return to if 13 is in the on the midpoint, which is 1, 11, 16 to 20. If 13 is in that sub list, we return true, but it is not, so we return false. Okay, so that's the review of our code. Let's now go and run it and see whether our idea is correct. So we'll run our code now. We have not corrected this. We're supposed to correct this one. This is row or the last element. Sorry about that. So we see that our idea works. So let's now see whether it passes all cases. So we have a problem with our index case. And the length of our matrix is supposed to be, so we need to manage that edge case. The length of our matrix is, okay, the length of our matrix is 1, but we need to check inside. Okay, we can just include here that if the length of the row is 0, just to manage that edge case, we return false. Because we have picked each row in the stuff. What's going on there? So our row, I'm patching that edge case. How do we manage the edge case? We can say that if the length of the matrix equals to 0, then cross, we have an edge case of 1, 1. How do we manage that? So I will be equals to, oh, I think we're having that problem from here. We should be adding here. I guess we should be adding here. Our I is equal to loop. Is it that we keep I as 1 here and we subtract here? And we can subtract. I is 1, 1 minus 0. If the midpoint, we work through that. If row of midpoint is greater than target, return true. Oh, I think we should adjust this one to the edge case. Greater than or equals to. I need that case. Or we put the equals to in the first one. That should manage that. Yeah, that should manage that. That's an edge case we needed to look at. And I'm not sure we need that. Let me see if we need that. Oh, definitely we need that to check. All right, that is it. Thank you very much for listening, and give us a thumb up, and see you in the next one. Thank you.